So we have one small concept left here, that is beats. You know what are beats? When two waves of same frequency and amplitude traveling in same direction superimpose. I have one wave here, sound wave. I'm talking about sound wave here, no? Another wave traveling in the same direction. They must have same frequency and same amplitude traveling in same direction. Just like you had, standing wave, they were traveling in opposite direction and they were merging together, right? They were traveling in opposite directions. Hope you remember the tag flows thing, no? Same type, same amplitude, same frequency, traveling in same line in opposite direction, same wavelength, same speed. When they superimpose, we have standing waves. But here, this is about sound waves traveling in same direction. Look at this. When two sound waves of same frequency and same amplitude, not same frequency, nearly same frequencies. Okay, when two waves of nearly, that should be very close, less than, the difference should be less than 10 hertz. That is all about persistence of hearing, something called persistence of hearing. Anyway, when you have two sound waves traveling in same direction with slight difference in frequencies and same amplitude with slightly different frequencies. Okay, slightly different in the sense the difference should be less than 10 hertz. Okay, for example, two tuning forks are there. One is 256, second is 254. The difference is 2 hertz. Okay, when they superimpose, such waves superimpose to form something called beats. Okay, beat. You hear alternate rising and lowering of sound. You hear alternate rising and lowering of sound like this. Okay, now this is called a beat. All right, like this. So the time interval between two beats is known as beat period, and the frequency of beat is known as beat frequency. Beat frequency is given by f1 minus f2, beat frequency, and time period will be what? Beat period, the reciprocal of this, 1 by f1 minus f2. I'll tell you one more time. We have one more point here. You know what is beat? When two sound waves of same amplitude and nearly same frequencies traveling in same direction join together, we have a particular kind of wave called beat wave. So you hear some sort of beating, some sort of rising and humming sound, rising and lowering of sound. Okay, this is called beat, and beat frequency is given by, this is proved in class 11, beat frequency. Beat frequency is given by f1 minus f2, difference in frequencies. And the reciprocal of this is called time period, beat period, the time interval between two beats. The time interval between two beats is beat period, and the reciprocal of it is called beat frequency. All right, so f is equal to f1 minus f2, t is equal to 1 by f1 minus f2. And you know, there are two things to be known here. One is, you take a tuning fork. You take a tuning fork here. This is a tuning fork. All right, which when excited will produce sound, which will excited will produce a wave. Okay, and you add some wax on it. You add some wax. There are two things that you do. You add some wax on it, or you file the tuning fork. File the tuning fork. Okay, you file the tuning fork means you are removing some mass from it. Filing. Okay, file means you're rubbing it off. Okay, you're chiseling it off, right? Okay, there are two things you can do to the tuning fork. These are actually different questions. One is waxing the tuning fork. Waxing the tuning fork. Wax means you are adding a little bit of wax on top of one of the prongs. Okay, one of the prongs, will have some wax added on it. And when you add wax, frequency will increase. Sorry, frequency will decrease because there is more weight now. So vibration will be difficult. Frequency will be less. So when you add wax on it, frequency will be less. And when you file it off, you can use a file to rub the material off. Okay, when you scrape it off, there the frequency will increase. So just know this thing. One is the equation for beat frequency is f1 minus f2. And then waxing and filing. Waxing means you are adding wax to one of the prongs. By doing this, you are reducing frequency. Never ever forget this. But by filing, you are increasing the frequency. All right. Okay, so let us go to the paper and do the questions here. We have a couple of questions. Let us look at question number 8 on set B. Set B. A tuning fork. This is the typical question that they ask all the time. A tuning fork arrangement pair produces 4 beats per second. Okay, tuning fork pair produces 4 beats per second. So beat frequency is given. Beat frequency is 4. Beat frequency is 4. Okay. With one fork of frequency, 288 cycles per second. CPS is cycles per second. Another name for hertz. Hertz. Okay, it's actually hertz. So one frequency is 288 hertz. So the question must be to find the other frequency. A little wax is placed on the unknown fork. Little wax is placed on the unknown fork and it then produces 2 beats per second. Second case, it produces how many beats? 2 beats per second. First case, it was 4 beats per second. In second case, the beat frequency decreases. I'll explain the question one more time. Look at this. You have to keep this in mind. When you add wax, frequency decreases. When you file it off, frequency increases. Both questions can be there. But this question is about waxing. That means you're adding wax. Another question can come with filing of one of the forks. Anyway, read the question again. A tuning fork arrangement, a pair of tuning forks produces 4 beats per second. So beat frequency is given 4. All right. And one of the frequencies is 288 hertz. And a little wax is placed on the unknown fork. Some wax is added. So it is the first case, obviously. And the beat frequency reduces to 2. The frequency of unknown fork is. I'll tell you how to do this question. Look at this. If you know what beat frequency is, F1 minus F2. Modulus of F1 minus F2. So there are 2 probabilities, right? There are 2 probabilities. The other frequency, F1 I got, it is 288. Then F2 can be 288 minus 4, that is 284. Or F2 can be 288 plus 4, 292. So there are 2 probabilities here. I'm left with 2 options. First tuning force frequency is given, it is 288. All right. Second frequency can be either 284 or 292. 284 or 292. Let us check. 288 minus 284. It is 4. 292 minus 288. That is also 4. I need the difference to be 4. There are 2 numbers which can give me a difference of 4 with the 288. Oh, 288 minus 4 is 284. 288 plus 4 is 292. Right? So there are 2 frequencies which can give a beat frequency of 4. Now I have to select between these 2. I should try my luck on one first. Then if it doesn't work out, I should go to the other one. Okay. That is how it works. Okay. So I'll repeat that part one more time. Look at this. Beat frequency is given, that is 4 hertz. Beat frequency is 4 hertz in first case. And one frequency is 288. So the other frequency must be what? Sure, it is 288 plus 4 and 288 minus 4. 288 plus 4 is 292. 288 minus 4 is 284. Okay. Look at the difference now. 288 minus 4, 284. That is 4. 288 plus 292 minus 288. That is also 4. So I have 2 options here. I'm going to choose the best one. I'm going to choose the right one. So I'm trying my luck with 292. I'm choosing 292 to be my answer. 292. I'm thinking about this option as the correct one. Now let us check if it is correct. Okay, 292 is my answer. Now if it is wrong, I should choose the other one. That's it. Okay. So now let us look at the second case. What happens when you added wax? Here you added wax. Wax added means what? Frequency decreases. When you added frequency decreases. Say, just imagine frequency decreases to say something 291 or say 290. 290. Just imagine the frequency decreases. Wax added means frequency decreases. Frequency decreases. 292 decreases to what? Say something like 291 or 290 or 290, 289, whatever you want. Anyway, I randomly take 290. So the new frequency is 290 now. Original is 288. Okay, first one original is 288. So the difference is what now? It is 2 hertz. The new beat frequency is 2 hertz. Exactly, spot on. We got the second case, the beat frequency, they have given it as 2 hertz. What you got is also 2 hertz. So my answer is correct. Second part, I'll explain one more time. Look at this. First of all, we have 2 options, 288 plus 4 and 288 minus 4. First tuning for frequency is given 288. Second one should be either 288 plus 4 or 288 minus 4. So 288 minus 4 is 284. 288 plus 4 is 292. I'll try one by one. I'm choosing this one to be my first trial, right? So it is 292. Now tell me what I'm doing in this question. I'm adding wax. Wax added means frequency decreases. Frequency decreases. Just put some random number. It was 292. Let it decrease to say 290. Now check the new beat frequency. Now it is 290. The other one is 288. New beat frequency is what? 290. New frequency here minus 288. That is 2. Exactly correct, because this is what they have given. The frequency is, new beat frequency is, original was 4, new beat frequency is 2. Yes, our assumption was correct. So the answer is 292. Here the answer is option B, 292 cycles per second. But here 284 is not given. So you can directly write there itself. Okay, but in most of the cases, they will give you 284 and 292. You will have to choose between them. This is how you do it. Now, question number 2. Question number 2, that's again a repeated question. 41 tuning forks are arranged such that each produces 5 beats per second when sounded with its near fork. Okay. 41 tuning forks are arranged. 41 tuning forks are arranged such that each produces 5 beats per second with the nearby one. That means the first tuning fork, this is first one, second one, third one. Likewise, you go until 41st one. There are 41 tuning forks arranged, and each one makes 5 beats per second. So these are having a beat frequency of 5. Then these are having a beat frequency of 5. With the nearby one, it is 5, 5, 5, 5, 5, 5. Okay. If the frequency of the last fork, frequency of the last fork is f dash is equal to what? Double the frequency of first fork. Double the frequency of first fork. Frequency of the last fork is equal to double the frequency of first fork. Then the frequencies of first and last fork are respectively. Read it again. 41 forks are arranged. Fork number 1, tuning fork number 2, tuning fork number 3, go until 41st fork. And then each tuning fork is producing 5 beats per second with the next one. This one with this, it is 5 beats. This one with this, it is 5 beats. This one with this is 5. So the difference between the frequencies is 5. Beat frequency is actually difference between frequencies, right? Beat frequency is difference between frequencies. So if beat frequency is 5, between these two, it is 5. The difference is 5. Between these two, the difference is 5. Between these two, it's 5. So every tuning fork has a difference of 5 heads with the nearby tuning fork. Okay. And something else is given. Last tuning fork's frequency is double that of the first fork. Then frequencies of first and last. You have to take something from class 10 here. You have learned arithmetic progression in class 10. Arithmetic progression, AP in class 10, where you learn the last term as a plus n minus 1 into d. Last term as a plus n minus 1 into d. Do you remember this? In a sequence, arithmetic progression. 1, 2, 3, 4, 5, 6. They are in an arithmetic progression. Here, look at this. The common difference is 5. Everyone differs by 5 from the previous one. No, this one plus 5, next one, plus 5, next one, plus 5, next one, plus 5, next one. So I'm taking the last one. This is the last one. No. So I can write frequency of the last one is equal to frequency of the first one plus n minus 1 into common differences, beat frequency, common difference. Look at this. I'll repeat one more time. This is something that is coming from class 10. In class 10, you learn nth term of an AP. Nth term of an AP. This is an arithmetic progression. Look at the common difference, 5, 5, 5, 5. Every fork has a difference of 5 with the next one. 5, 5, 5, 5, 5, like this. So Tn, nth term is given by a plus n minus 1 into d. So nth term is frequency of nth tuning fork is equal to frequency of first tuning fork plus n minus 1 into common difference. Common difference means the difference between them. It's actually beat frequency. So let us put, what about the last one, nth one's frequency? They have given that nth one's frequency, last 41st one's frequency is twice that of the first one. So I can write 2f1 is equal to f1 plus n minus 1. N is common difference, it is 5. Sorry, n is the number of forks. N is the number of terms. 1, 2, 3, 4, 5, 41 terms are there. So 41 minus 1 into F is beat frequency. Beat frequency is 5. So 2f1 minus f1. This f1 goes to the left side. 2f1 minus f1 is f1 is equal to 41 minus 41, 40 into 5. That is 200 heads. If I get f1, I can find fn. Last one, it is 2 times f. That is 2 times 200. That makes it 400 heads. So the answer is 200 heads and 400 heads. Option A is correct, 200 and 400. Repeating one more time. These tuning forks are arranged in such a way that every tuning fork has a difference in frequency of 5 heads with the next one. Okay, this plus 5 next, this plus 5 next, this plus 5 next. Goes on like that. 41 of them are arranged. So that is in an arithmetic progression, AP, for which the last term is given by first term plus n minus 1 into common difference. Last term is fn. Frequency of last one is fn. Frequency of first one is f1. N minus 1. N is the number of terms. Number of terms is number of tuning forks there. D is common ratio. Common ratio is the difference, common difference. It is actually the difference in frequencies, which is actually beat frequency. Difference in frequency is actually beat frequency, which is given in the question. So Fn is equal to f1 plus n minus 1 df. Fn is equal to what? They have given that the last frequency is double the first frequency. So Fn is equal to 2 times f1. It's equal to f1 plus, there are 41 tuning forks. There are 41 terms then. 41 minus 1 into 5. So 2f1 minus f1 is f1 is equal to 40 into 5. That is equal to 200. Having obtained the value of first frequency, you can find the last frequency by putting it over here. Fn is equal to 2 times f1. That is 2 times f1, 2 times 200, that is 400. Answer is option A. And here comes the last question of this module. That's about standing wave again. That's a typical one. Just read it. A wave is represented by a given equation. Y is equal to A cos kx minus omega t. This is a traveling wave. But you may ask one question. You know, in traveling wave equation, we had sine. Can we have cos? Yes. Cos is another option. Okay. But anyway, in general, we learn sine. So cos is also a possibility. So read it again. A wave represented by the given equation. Y is equal to A cos kx minus omega t is superposed with another wave to form a stationary wave such that the point x equal to 0 is a node. X equal to 0 is a node. So a wave, this is a wave, no? This is a wave. Okay, the wave is going to the right. Wave is going to the right like this. The wave is going to the right. Okay, that wave is represented by this. It's actually a sine function, but anyway. Okay, it's okay. It's superposed with another wave to form a stationary wave such that the point x equal to 0 is a node. Equation of the other wave. You know, if you want a stationary standing wave, you need another wave to superpose with this, right? So that wave must be coming back, right? It must be coming back means what? The second wave, this is y1. Coming back means it should be A cos of kx plus omega t, because I told you, no, for a wave moving to the right, it is kx minus omega t, or omega t minus kx. Wave going to the left, it is plus. Apart from this, the amplitude, you know, for this one, for the incoming wave, the amplitude was downward here, and that got inverted here, no, upward. That means amplitude should be reversed in sign. So that must be minus A cos kx plus omega t. Answer is option B. Even otherwise, cos kx plus omega t is there only for option B. The other should be cos function. No, one is cos function means the other is also cos function. There itself, options A and D are ruled out because they are sine functions. So the competition is between B and C. C is also ruled out because it is kx minus omega t. The second wave should be coming back, right? Then only they can join. Do you remember tap flows? I told you tap flows. When tap flows, I forgot, tap flows. You know, when two waves of same type, same amplitude, same period, same frequency, same wavelength, same speed, traveling in opposite direction, in same line, in opposite directions. That means if this wave is going to the right, second wave must be going to the left. Okay, second wave must be going to the left. So this is going to the right. So how do we write a wave going to the left? You just have to invert the sign and change the sign. A cos kx minus omega t is for a wave traveling to the right. If you need an equation for the wave traveling to the left, just make this minus plus. So it is a cos kx plus omega t. And this a becomes what? A becomes negative. Why? Because this wave goes over there and it gets reflected. When it gets reflected, there is a phase reversal, phase difference of 180 degree. Okay, because this wave is going down there and it is coming back, means it is getting inverted. Then only they can superpose and produce a standing wave. So answer is minus a cos kx plus omega t, option C. Did you understand? Hope you understood everything from the discussion. That's all about waves. If you practice this paper and learn the theory discussed in class, the material is given alongside, you will definitely get the question from this topic. Okay, I'm winding up for the day. The chapter stands completed. So that's all about class 11 modules.